So it gives me great pleasure to introduce a former student working for us as a gameplay programmer at Funcom, Mathias Mohn Mørch. Thank you very much. Hello.
Okay, nice. Hey guys, super cool to see so many people showing up. I've been wanted to do something like this for about 3 years now, but I've never gotten the opportunity. So really happy to finally be able to talk a little bit, yap, if you will. So yeah, I chose to structure this talk into mainly 2 parts, as you can very clearly see here. The first one is how I got into the game industry. I've also been asked what did I send in and like what were my application, what were my CV, how did my GitHub look, right? So I will be showing that. So and then be talking a little bit of from the other perspective, like when you're being hired, what do they look for? I've talked to people at Funcom with what they look for and some of my own experiences. And then the latter part of the talk will be programming topics I wish I learned during university. This will be with the focus of when you're getting into your larger projects. I think that's the first year and the third year where you're mainly making the big projects. I noticed I fell into some traps there, you could say. And I just want to show what I've learned so that can probably be of use to you guys. That's the hope, at least. So let's get into it. Hey, it works. Nice. So first off, a little bit about me. Like the wonderful people already said, I'm an alumni here at Inland University. I studied programming. And I've been working at Funcom for about 2.5 years now. And I've been programming for 7 years, where 2.5 of that was professional, i.e. Funcom, and also a little bit of a startup company. You could say, if you will, that I'm fluent in 5 languages. In no particular order, it's Norwegian, English, C++, C#, and a little language called Odin. And I like grappling hook games way too much. As some of the people who has worked with me before probably know, I've made a total of 3, 2 of them in Unity and 1 of them from the ground up because I find it fun. And I also like split ergonomic keyboards way too much, as a little fun fact, if you guys know what that is. So yeah, let's get into it. So part 1, getting into the game industry. So like I said, I'll be showing some of the stuff I sent in. This mainly includes a CV, a game video demo. I've heard the network is a little bit shoddy, so we'll see if you will be able to see it, but heyo. The GitHub page and originally my cover letter, but that's been lost due to I sent it through an application website and my account has been deleted due to inactivity. So sadly, don't have that one anymore. So yeah, first off, let's take a look at the CV. And something you might notice, and this is something I'll be coming back to, is it doesn't need to be like super good or super impressive. This is a quite like standard-ish CV. It's white and black and a little bit of like white, blue. But something I want to point out is you can see that I have a YouTube link on it. And I think that benefited me quite well. And I also have my GitHub, yada, yada, yada. And then when you actually get into writing about yourself, of course, like everybody says, put your best foot forward. I also want to take attention to like trying to be a bit personal too. Like, how are you as a person? I say I'm enthusiastic about learning and trying to keep a positive mindset, if I remember correctly. And then when you get into your milestones and stuff, try to get forward everything that you know, right? So in my case, I was very lucky to work with a wonderful team and we went to Norwegian Game Awards with the game and won Gamer's Choice. Of course, mention that. And also, I don't know if we still do it here, but we have the like Game School EXPO competition thing with different, we still have that? Hey, nice. Maybe I'll be there to take a look. That sounds great. If you win one of those, yes, like please add it. So try to put your best foot forward. And also remember, when you're applying for a company, it's a teamwork thing. So if you can show that you function in a team, super important. That will help you a lot. And then like some other standard stuff. If you want to read this, you can. Jose has access to the presentation, so I assume all of you will get access to it if you want to read it. Next up. Oh, you gotta be kidding me. You don't have permission to this file. Well, damn. Well, I'll just have to paint you a picture instead. So I do have, I can probably show it afterwards if we have time. I have a memory stick with the file on. But yeah, so basically, my CV video is 2 minutes. It consists of 2 parts, where the first one isn't gameplay programming at all, and I'm a gameplay programmer, right? It's this like compute shader grass thing. If you've seen Ghost of Tsushima, like the fancy ass grass there, we had the artist on our team who was like, wouldn't that be cool? And I was like, okay. And then 6 months later, and then I got something working. And that's the thing I chose to show first, right? Not something gameplay programming related. And the second part was a boss that we worked on for the game where I programmed that. So, man, sorry I don't have the video, but let's go on further. Yes, okay, I have to like just click 5 times. All right. So very quickly, the GitHub. I didn't put much weight into the GitHub at all. Like, of course, I don't have access to how it looked 2 years ago, so I just inspected the element, like changed the wording on the left-hand side for the bio there to match how it was at that time. But as I'll keep getting back to it, it doesn't have to be super fancy. Just show what you have. And for the projects here, I had some stuff I made in folk high school. I think that's how you say it in English. Just like a little fun thing to make a time-lapse, the screen recorder one. I don't know why I didn't just use OBS or something, but wanted to have fun. Kinetic Traversal was the grappling game, the racing game from the first year, and then one repository I actually put some effort into is this one. And by what I mean by effort here is just taking some screenshots, making a GIF. This is actually a GIF, but it's a picture to just show it. This specifically is to do a fancy form of lerping, where you can use like a mathematical thing called second-order dynamics to kind of like give interpolation a personality. So you can say here it will kind of like wobble, and that's really, really cool. And I saw a video about it, so I like didn't actually teach myself the math, but like, hey, I want an editor tool so I can actually see the personality before I play the game. Just like small, simple projects that I had fun with. So that's what I sent in, and I want to talk a little bit about my journey into Funcom. So first and foremost, I saw the internship, but I was like, I can't apply to this, right? How the hell will I get in? Like, there's many applicants, yada yada da. But then a really good friend of mine called Thomas, he was like, no, you have to apply. So I didn't have a choice, and I sent in an application. So this will just be a bit about the process, like how is it? So for an internship, it's different from a traditional job. Internship is much more light. They won't like drill you as much on the technical subjects, whereas a normal job, they will. So first I got into a normal interview with HR at Funcom. At this point, the people at Funcom have most likely looked at your application too. But the HR interview you could think of more as like a vibe check, almost like make sure you're a normal human being, like you're a all right person. And that went fine. They mostly talked about like, oh, how is it working at Funcom? This and that. It was very nice. And then we got to the second interview, which is the technical one. For my case, I got interviewed by the head of studio, which is like running the studio, doesn't actually do anything on the game, just keeps the studio alive, or like keeps it nice. And the technical director at that time, which is like the big shot programmer guy. And as I say here, you can duck up. I totally ducked up on the technical interview. You don't have to ace it at all. For example, I got asked a question, which is, what's the difference between a pointer and a reference? For the non-programmers of you, this will sound like Greek. Sorry. And I was like, I don't know. I don't know. And I still got the job. Hey, right. So remember, it's allowed to do mistakes. And to also follow up on the making mistakes thing, a little story about that. Funcom was here at the stand in 2024, 2025 for Game School EXPO, I think. And I was a volunteer, and I was like, "Hey guys, you need any help?" And like, yes, we can't get the HDMI to work, so I helped them, plugged in the HDMI cable, and the technical director was there. He's the guy I talked to, though I didn't know at the time. And then a game came up on screen, and this was Conan Exiles, which came out in 2018. I didn't know anything about Funcom because I hadn't done my research, and this was in 2024. And I said with a straight face to him, like, oh, is this the new game you guys are working on? And I don't remember what he said because I was like, because he said, no, this is a game from 2018. We worked for it for like 5 years. We're like, oh. And I don't remember much after that because that was quite scary for me. But they still got the job, right? So I really just want to push that point home, that you're allowed to make mistakes and you're allowed to duck up, and it'll still most likely be all right. And also when applying for jobs, remember that sometimes you will just get unlucky. If the company is like, it's not growing at the moment, then it's harder to get in, of course. So don't take it personal. And then lastly, a bit about what they are looking for in a candidate. So remember, this is not a rule, but my experience. So remember that if you're applying for like a banking job or whatever, that might be a bit more like Wall Street vibe, right? I'm applying for a game company. But remember that what they are looking for is a person who is, of course, good at what they do, but they also want to learn about, like, they also want to know, like I mentioned in the CV, that you work as a team. Because if you're this like genius programmer or artist, right, but you can't work with the people, you don't function as a team, you can't keep deadlines, you always think you're correct, that's not very nice to work with. And you'll probably screw up for the entire team because everybody else has to like conform to what you're doing. So make sure that you work as a team member. And also remember to show initiative. This is something you guys probably all have heard, like, oh guys, remember to show initiative, right? It's super important. But I think the reason it's so important is that when you are at work, having initiative is super important because let's say you see some code that doesn't really make sense, but it's not my job, I'll let it pass. Or you see some shoddy documentation and you know how it should be, but you're like, oh no, I'll take it later, right? But if you take the initiative to fix those things and dig down, maybe you'll find a better solution to a problem. Maybe you'll make some documentation or clean up some shoddy one that will actually help people. And that's a benefit to the whole company, right? So taking an initiative, very nice to show. So being a volunteer for stuff, even though sometimes you might talk to a technical director and a company and make a fool of yourself, it's still worth it. And also a last point is people say like, make sure your CV should match the place you're working on. And I would say, if that's the case, great. Try to have projects where that you can show something for it. But just to give you paint you a little picture, before working at, or Funcom is a company that mainly makes multiplayer online survival games. Before joining Funcom, I had never touched multiplayer code. Survival games are not really my thing. I like Soulspawn and Kerbal Space Program, right? And that's me. And I still got the job, right? So they aren't looking for people that has the existing skills. They look for people that show that they can learn and they can do cool stuff. For example, the magnum opus I sent, my grass thing, which I sadly couldn't show. That's tech art, right? That's not gameplay programming. So of course, try to have something to show for it. But don't think because you haven't done the things they do that you're not relevant to them. They're looking for people with potential and skill. And also remember, you're not a professional yet. This is I think this is very important. Don't keep yourself to the standards that you may be put on yourself, right? You're not the intermediate, you're not the senior, you're not the junior, you're a student. And they should expect that. So don't be too hard on yourself. Make mistakes, but try. That's the point I want to get across here. And that's it for part 1. So I won't be taking any questions now. I'll keep all that jazz at the end. So the next topic is probably more relevant for the programming people here, but I hope it's still fun to listen to, at least. So program topics I wish I learned during university. My goal here is not to tell you exactly how these things work. I more wanted to give you hooks that you can remember, and then you can come back later and learn more about it. Because I don't have enough time to actually teach it. So this will be a bit more like, this will be a few subjects I'll talk about, and then you can learn more about them later. And hopefully when you get to a situation where you're like, oh shit, this is a problem for me, maybe this can help you, and then you can learn about it. And also it's targeted towards when you're doing your larger projects. So I've been asked to talk about how I solve problems. So I have some thoughts that I want to give here. And the first thing is use pen and paper. And to build upon that point a little bit, there's a quote by like some Linux person, Linus Torvalds, like the freaking creator of Linux, really good guy, so you should listen to him. And the quote is, "Bad programmers worry about code, good programmers worry about data structures and their relationships." And I think this is super important, especially in the age we're going into where AI is like, oh no, AI will do more and more, but then the system architecture side, the data structure side is even more important. And like, why is this important? That's because when you know the data structures of your program, you know how they look, then the code will naturally follow those data structures. For example, in Unreal, you have this whole like big inheritance thing. So if you make a new class, it might be, or you might inherit from a actor, and that will greatly define how you write the code of your program. But if you write in Unity, which doesn't have the same concept, it's more like component-based, then you can't do the same thing. Your code has to follow the data structures of your program. And if you choose or make yourself a shoddy data structure, your code will usually be shoddy too. So remember, use pen and paper, draw it out. You don't have to use pen and paper. It could be like an online tool to draw stuff, or just like write out the data structures, but don't write the code. Whatever, right? But I would strongly suggest you do it. And also remember, the first time you do something, it will most likely be really bad. I think the Primogen said once that to make something good, you have to make it thrice or 3 times. I think that's quite true. But doing the pen and paper and thinking about the data structures can really help speed that process up. And also, I think most of you have been told this too, but like, please, I did this mistake. Aim for simple solutions. You're like, remember the timeline you're on. You're not making a 6-year game. You're making a half-year game, maybe a year game, maybe 2 years if you start early, right? And your solutions should reflect that. And then for the last point, it's designed for target platform, resources, and scope. You know, most of you guys are designing games that are for like a mid-end PC, so that will be fine. But remember the scope, right? Really remember the scope. If you're making a system for a, like, let's say, inventory thing, and you're maybe expecting 5 different items in total and maybe 20 in runtime at once, don't make it super complicated item system, right? You can make it simple and spare yourself a bunch of time. Just need some water. So, next up, I want to talk a bit about an alternative to structure a program. And the reason I said this is not because this is the best one. I think it's really good for certain situations, but I just want to make you guys know that there are different ways to structure programs, and if you take the time to learn them, that can help you apply the best data structure, right? Or the best solution for the problem you're working on. So first, define what we're usually doing or what we're being taught. That's the OOP, object-oriented programming. I just want to take a quick raise of hands. How many people here think that object-oriented programming is kind of going out of fashion? Like it's doo-doo, if you will. A couple of ones. Nice. That gives me more to talk about. Great. So I'm not saying object-oriented programming is bad, but I'm not the biggest fan of it because I think it has some issues. And one of the issues is huge inheritance structures. That's what I mean when I'm talking about object-oriented code here. There are a million ways to define it. If you ask different people, they'll give you like different ways. Like, oh, in C, if you just make a struct that doesn't have member functions or inheritance, it's still an object, right? But I'm talking about this specifically. And this can introduce some problems. Have you guys heard of something called like the inheritance diamond of death? Some of you, nice. It basically means if you have 2 different children and suddenly they need to implement the same behavior, you're in a bind, you could say, because suddenly you have to like move a bunch of code or data around to make it so that both those classes has the same thing, or you have to re-implement it. And this is something Unreal has to do because they chose to use an inheritance hierarchy. I'm not saying it's a bad choice always, but just remember that there are alternatives. For example, actor, as all of you know, has a position in the world. Insane, right? But the scene component also has a position in the world. So they had to re-implement it twice, and that's duplicate behavior. And if you suddenly need to change one, you have to remember to change the other one. but you're a human, so you'll forget to update it, and then you're in the bind. So the one alternative way to structure programs that I think are quite cool is something called fat structs or flat structs. And what they mean basically is, let's say you want to have a sword, a shield, and a health potion in your game. Instead of like making an inheritance hierarchy or doing a bunch of like component stuff, you just smack all the data in a single struct. Done. Right? It could look something like this. This is just an example to like show how it could look. But you're straight up just, I want to have a consumable, I want to have a weapon, I want to have a shield. You have some flags to enable or disable those functionalities. And then you just smack everything into the same struct. That's it. And why is this so great, right? First and foremost, you can see like most things, like both sword and a shield might have a durability thing. The example I'm working off here is something like Soulsborne, right? That's where I'm coming from. And if you need something more, you just add it, and then you have it. So some considerations about it. It's a super simple data structure, right? It's as simple as it gets. Like maybe the total will just be like, if you want to teach it to somebody, yeah, I have this struct. It works like this. If you want to add stuff, just plop it in there. There's no like, oh, you have to remember X, Y, Z when you're doing the inheritance stuff. It's also, like I said, easy to extend. If you need more stuff, you need more data, you just slap it in there, maybe add another flag or two to toggle some functionality. Let's say you want to have a sword that also functions as a shield. You can just enable both those flags and then make sure your code supports it. And you can start at the implementation right away, right? You don't have to ducking. You don't have to ducking, like begin moving members around, making new parent classes, whatever. No. You just start at the implementation. But like the impression I was under during university is that any wasted memory is bad. That's like, not good. I've kind of begin thinking otherwise. You should remember the scope and the platform you're targeting for, right? So for example, in Unreal, to just show a bit about the wasted memory thing, every U object you instantiate is 48 bytes. That's about 12 floats. Not a lot, right? But an actor is 1,048 bytes. And how many actors can you have in a scene at once? 1,000, 2,500, maybe more, right? They, of course, have systems to mitigate this. But like 100 actors in Unreal is 0.1 megabytes. 1,000 actors is just above 1 megabyte of memory, right? Or 0.0001 gigabytes. It's nothing, right? And especially if you're thinking for the game you're making, it's a short scale game. You most likely want to have a bazillion different instances of stuff at once. This is perfectly fine. So the same way, if you have a fat struct that's quite big, let's say 500 bytes. Presentation struggles. You would have something. You would have to have like a million different instances to actually reach a gigabyte, right? And now we're talking a lot, but that's an insane amount of instances. And most likely, you're never going to reach that. So maybe you should use fat structs here and there because it can save you a bunch of time, and you don't have to spend time like re-implementing stuff. So then next up, I'm going to talk about a super exciting subject that I think all of you will love, and that's logging. Very cool, right? But I promise, guys, this will be nice. So especially when I got into my later parts of making games in university, I got into like the log spam hole where your log is just completely nonsensical. There's like logging in tick, and you just end up not looking at it, right? So I want to talk about some things you can do to maybe help with logging a little bit. So first, let's just define logging severities. Like when you make a log in Unreal, it might look something like this, right? You type UI log temp. A lot of languages has similar functions, but I'm using Unreal because I've been told that that's what you guys use. You use log temp and then your log severity, and then you know that warning is yellow, error is red. Very nice, right? And this is okay. Don't log in tick though. Never log in tick unless you're debugging something and you're removing it afterwards. But just remember these severities. And I would say that a good log is a log that matches its logging severity and is not in tick, because you should never log in tick. So how can we make better logs? So when we go back to this one, you see you write log temp, but you can actually make, this is something called a logging category. Very cool. But you can make your own logging categories. You can make them, there's many ways to make them in Unreal, but you can, or before we continue, how many here know of logging categories? A few ones. Then it's definitely worth for me to talk about this. Very nice. So you can do it like this. You just slap a header file, a CPP file, you write those things. Don't care about the semantics. But what I want you guys to see or notice is the logging. You type log inventory, log all. The log here is your severity cutoff. And this means if you try to do a log, UE log, this will be printed. But if you try to do a very verbose or a verbose one, it won't get printed because this is your default logging cutoff. And why is this useful, right? Well, if you do this in Unreal, I won't do the fatal one because that crashes the game. Then you see you don't get the verbose ones. Nice. All right. Okay, so let's say you could make it for different systems where, I need to figure out something, like something isn't working for the inventory system, then you can increase the logging and suddenly get more information. And you can do it like this in your command or a console window. Just write log name, new logging severity. You can also do it with the built-in console, I think it's called, when you're playing the game. So this means if you have a playtest and you're suddenly encountering some issues, if you've been good about the logging, you can just, shit, something is going wrong here. Let me increase the logging. Then I have more logs to look at afterwards. And that makes it so you can avoid log spam, but for the systems you care about that are not functioning or behaving correctly, you can get some more info. And that's pretty nice. Like AI is very good at scanning things, but still you want to have a concise logging window. Because if you have to ask AI to skim it, that takes time. Where if you can just see the log right away, like, shit, the player didn't load correctly, then you know right away. And you can also do the same with decreasing logging. So if you see you have too many logs, just set the logging verbosity to something more severe and you're done. So let's look at some quick examples about what you can do to improve your code. For example, I would say this is a very verbose log because you jump all the time in the game, right? So just keep it at very verbose. It won't be printed. But suddenly, if you have an issue, your player doesn't jump anymore, you can start off by just making the verbosity very high, and then you'll see it if it actually reaches this point in code. You can also use a debugger for this. For example, this is by no means industry professional code. This is just to get the point across. But you see, this seems like fairly normal code, right? But if something goes wrong here, what some people call it is it silently fails. So this will it won't crash, right? But also from this point on, if this fails, your player won't have a functioning inventory. Maybe your game has a concept of like key items to open doors, like Dark Souls has, then you're in a bind again. Because maybe you'll play for 15 more minutes and you'll kill a boss, and then your inventory isn't working and you don't know why. So you can add some logs instead. So if something went wrong, you make sure it gets printed. If it goes as expected, you just do a very verbose or a verbose one. And then your log will go from this to this, like, cool. And like, this doesn't sound too impressive, but remember, you literally add 2 lines of code to make a logging category. And now you can make your logs much better. And also, when you use logging categories, it'll actually say the log. So it gives you much more context about what part of the code is going wrong. So you don't have to write out the like, this is the character, something went wrong here. You just have it. And then I want to talk about my last subject. And this is something I really wish I learned during university. So I think this can really save you a lot of time. How many people here know what assertions are and use them? How many people here know what assertions in the code sense are and use them? Nice, that gives you more to talk about. So I think all of you guys should use assertions to just get to the meat of it. An assertion can help you reduce your debugging time. When you have an issue in your code, if you use the correct assertions, you can probably just like cut off 90% of the whole like what is actually going wrong here thing. It'll just tell you something is wrong. So what an assertion is just the rules or contracts or assertions of your program. And as soon as it's something you write out in code, I'll show you some examples soon. And as soon as your assertion isn't true, the program will, depending on which assertion you use in Unreal, it'll either crash, scream very loudly, and if you have a debugger attached, it'll jump to that point so you can inspect what's going wrong. So the easiest form of and yes, if it's a live game or a playtest build, you can't recompile in 3 minutes, add the log, attach the debugger, right? But if you have assertions, that will also print to the console. If for a live game specifically, you often have tools to send the call stack of what went wrong, if that makes sense, back to the developer so they can see like where in code did this rule or contract break. But we're not going to talk more about that. That's just good to know. So this is the simplest form of an assertion you can make. This is called a check in Unreal. And this means during development build, if this isn't true, the thing inside the check isn't true. Let's say Jose is pretty cool. It's true, very nice. If it's not true one day, the world explodes, right? It'll just immediately crash. And this is pretty cool, I would say, because right now, the items container is just a T array. But let's say in the future, you have to change it. You make your own class to implement items. If that suddenly has its own empty method and it doesn't work, you'll know right away. As soon as this bug arises, the program will scream insanely loud and say, something is very wrong here. So you don't have to spend a lot of time investigating like, oh shit, why have I been playing for 20 minutes and these temporary items are still in my inventory? You'll just know. So for example, to give you a little bit of an example that I think might have happened to some people is, let's say we have a projectile class that we want to fire in our character. And then your code might look something like this. This seems like fairly normal code, right? You take the projectile class and you spawn it. But there are multiple problems here, but one of the big ones is, let's say you forgot to set the projectile class. Are you sure what will happen here? Will it crash or not? I read through the code and tested that if this is nothing, it won't crash. Yay. But also your projectile isn't working. Pretty bad. So you can maybe you do this to make sure like, oh, I wanted to make sure it doesn't crash. Very nice. But we can do better. We can add an ensure. This is Unreal's second type of assertion. This won't crash the program. But if you have a debugger attached, as you always should, always attach the debugger, then this will if this suddenly isn't true, it will immediately scream and say, hey, something here isn't working. So if you as a developer expect that the projectile class should always be set, you do this, and as soon as that doesn't work, it'll look like this. Your game will pause, it'll jump to the place, and if you hover over the projectile class, you can inspect that it's not set to anything. This is a fairly trivial example, but what you can do with assertions is you can say, this is a rule of my program. This should always be true. And if it's not true, then, shit. So let me just give you a bit of a more proper example. I'm building on the Dark Souls example here. You have a concept of a boss, you have a concept of a character, you have a concept of an inventory. And this might look like fairly normal code, right? You might write something like this. But what if the boss is null pointer? What if the character inventory is null pointer, right? It won't crash, but it'll just silently fail. And then you have to spend time to find out why the boss is null pointer or why the character's inventory is null pointer, right? So you can just do this instead. And then as soon as something goes wrong, program will scream and you'll immediately know. the same goes for this, right? This is the same example that I showed you a little while ago. Let's say that you play the game, there's a boss level, you enter the boss level, you defeat the boss, you get the item or the key item, you go back out, you go to the door to open the fancy door to progress the game, and the game says, no, you don't have the key. And then as a developer, you're like, damn, why isn't this working? I was looking forward to making this new cool grappling hook system. And then you don't know at this point in your game what could be wrong. It could be anything. It could be that the logic to scan if you have the correct item isn't working. Maybe you have a door where you say, hey door, you need to look for this key to open. Maybe that's borked. Maybe you didn't set the correct content there. You have to check. And maybe your inventory isn't working, or maybe the item is actually missing. But then you might enter the boss level immediately without traveling to it through normal gameplay, and then it works, right? So the fictitious issue here is that specifically when you're loading in to the boss level, it doesn't work, right? The inventory doesn't load properly. And you have to spend all this time looking for what's going wrong? Why is this happening? Trying to go through all the different causes, or you could just add an ensure with the message. This is, you're literally adding one line. You're not even adding a line, you're just modifying one. And as soon as this isn't true, so as soon as you load into the boss level in this case, the game will immediately stop and tell you something is wrong here. And by doing this, you can cut down so much of your debugging issues. So remember to use assertions. They are super nice. These are some references for what I've taken inspiration from, and also really good talks, in my opinion. So you can look at them if you want. And that's it. Thank you guys for listening.
Let me just move away from the speaker here so it doesn't come through too much. Thank you very much. Most of these questions that I have for you are pretty much based on what it was like to actually get the job at Funcom, first of all.
Yeah.
Because unfortunately, programming is not my medium of focus. It's not I understand the relevance of it, because without any of the work that's done in coding, all our artwork just sits there on a screen and does nothing. So it's the beauty of being able to handle the mechanics and handle the effects and handle all the technical elements that bring together and put it into an application which is just beyond me how you do it. It really, like you say, it is another language, and I'm terrible at languages anyway. But I'd like to talk to you about a little bit about your application to Funcom, if I may.
Yes.
How long was the timeline when you first applied to them before you actually got, your arse on a seat?
That's a good question. I think I applied I knew I got the internship right before Christmas, in December. That's when I knew, or maybe the 17th of December. But when I applied, maybe a month before, 2 months.
That's
before.
quick.
But I'm not sure though about that.
That's not a bad turnover though.
That maybe more.
Because I've known studios, they'll take someone and go, yeah, we'll keep them on the sideline, and then when we start a new project, we'll bring them in. I've seen that happen before. But with regards to your demo reel as well,
yes,
there's something that I'd like to clarify as well. What was the runtime on your demo reel?
It was a minute, I think.
Interesting, because there usually is around about a maximum of 2, and you've got to put your best stuff forward in the first 3 seconds or even 5 seconds. They say you've got to put your best foot forward there. And what did you include? Did you focus on mechanics or the game menu? What's the area that you want to showcase your best work within your demo reel? So what did it feature within it? Are there things like mechanics and menu systems, and what else is in there?
We have 5 minutes, so I can just plug in the memory stick and actually show it. So people,
if that's all right with everyone else, and you can actually see the actual copy of it, or if it's available on YouTube. Excellent. Because it is important that when you apply for a game studio, you always want to showcase your best work at all times. And one of the best ways to do that is with various work, not just your demo reel, but also with your CV, your cover letter, your research on the company. As you were saying before, didn't realize that one of their major newer titles was actually being showcased, and went, oh, what's this one? Is this the newest one? No, this is one we did a couple of years ago. You have to do your research on your studio. You have to know who it is you're seeing and what their job is. Find out what their name is, find out what their job title is. So when you speak to them directly, you're not going, I'm here to see somebody about a job. You actually know who you're speaking to, you know what their skills are, and you know what they're doing.
And remember, even if you don't know, still talk to them.
Find out. Well, one thing I did forget from previously was that's for yourself.
Oh,
yeah, and I have another one here for you.
Let's see. Here's the video.
Are we ready to go?
Yeah, we're ready to go.
Excellent.
There's no sound in this, but come on. So I just made this video in Blender, and I just like picked the cool systems I made, and I tried to show them. So this is the grass system I made, and oh no, this is starting. You know what? You're right, Chris. I think I sent the 2-minute video to them. It's still the 1-minute video. It's this one, right? So I made this computer shader grass system. Oh, dude, why is this content so horrible? I know that when I was in school, I always was like, the teachers are so, they spend so long to set up stuff, to like remember, for forgetting to make it full screen or whatever. I'm turning into that person, man. Okay. Let's go. So this is the computer shader grass system I made. You can see I'm just showing off all the optimizations I made. This is a quad tree structure, like not showing the grass when the camera isn't looking at it, showing like some interaction in the grass I made, and then a render target that makes it function. Just to like show off the best stuff of the systems I made. So there's no transparent shaders here. This is all geometry, all opaque shaders. And it's about like 1.3 million or something. So like that's the thing I want to show. I also made that widget there to like set up the different wind types. So I didn't need to do it, but it was fun and it's something cool to show. And that's the computer shader grass. And this is the boss system I made with some really cool 3D models that some people here in the auditorium has worked on. And I made the boss here. I made the boss system. So I just showed off all the abilities, basically just showing off what I think is cool. And that's it.
What about putting underneath some of those images whereby you could actually display like maybe a very short like bullet point explanation, you know, effects, you know, or whether it is, because you're telling us what your involvement was there. Yes. But unfortunately, if you're watching it raw and without any kind of like context, it's very difficult to know, okay, what am I looking at here? So would you advise maybe in the demo reel to actually stipulate what it is that you did? I mean, I know for an art demo reel, if you haven't created the character or if you haven't done any of the environment work, and you've only worked on the animation, you should stipulate that you only did the animation for that particular scene. Is that true with coding?
I would definitely say so. Just looking at this, you might think I made the character controller, for example. I didn't. I only made the grass and the boss. So yes, I would say talk about your thought process, like I just talked about how I made it, but I also showed how I solved it with the quad tree implementation and the optimization to only show the grass that's in the view frustum of the camera. Just make sure to explain it and show it. That's really important, I think, at least.
Okay. We are a little bit early, but we're going to take a break now. Yeah?
Cool. Thank you guys for listening.